Okay, our next speaker is coming from Eastern United States. And I fell upon Dave's information while I was looking for the effect of lifestyle modifications on our gut. He is a world expert on this aspect. And I actually embarked on one of his programs, which is circadian rhythm retraining. And that's how I learned about him. So Dave has worked in the health and wellness industry for over 25 years. He's been helping people improving their health and well-being through online programs, YouTube videos, and podcasts, and very, very thought-provoking articles on the internet. He also does one-on-one sessions and corporate wellness programs. For the last 11 years, he's had a focus on gut health, working with functional medicine clinics, practitioners, to develop materials looking and to help people to optimize their gut health. He also shares online content through YouTube, social media, to help break down complex research on gut health and lay public. You can find Dave Mayo's information on the website and the YouTube channel hackyourgut.com. So hackyourgut.com. So please join me in welcoming Dave Mayo.
All right, thank you all for having me. Good morning, or I think we're midday over there. I want to thank you for spending time with me here. Time is one of our most valuable commodities, and I appreciate you giving me yours.
Computer? Yeah, just a little bit, 10 seconds.
So today, the name of my presentation is On to Greener Pastures, Establishing a Healthy Microbiome Post-IBS Treatment. Since your time is valuable, I am going to cover some of the basics, but I'm going to try to expand quite a bit on things that you may not be familiar with, just to kind of give you a little added value. So an overview of what we're going to discuss today. We're going to start off with what you ideally should be starting off with your patients and clients, and that is creating the right mindset. It is essential to do this at the beginning so that these individuals can get the help they need and that they can be motivated and stay on track. Then we're going to move on to the importance of circadian rhythms in gut health as well as gut pathology. We'll discuss some of the factors related to gut health that are regulated by circadian rhythms. And then we'll move on to nutritional strategies to make things stick. We'll talk about diet, different aspects of diet that you may not be accustomed to. We will touch upon supplementation a little bit. We won't really go over probiotics. The information there, the research is kind of hit or miss, and I hope that what I will present to you will give you an alternative to the use of probiotics. So in creating the mindset, IBS post-treatment is different than most other conditions. With most other conditions, say you get strep throat, you take a course of antibiotics, and then it's cured. You don't think about it again. But in a lot of instances, people have been treated with antibiotics over and over again for IBS, and it just comes back. Furthermore, since diet is what was kind of inducing their symptoms in the first place, and the gut microbiome is heavily influenced by diet, it's really important to get them to understand how important it is to stay on task with their diet. Additionally, they're going to be coming in, at least most of them that have kind of been through the ringer over the years with misdiagnoses and then eventual diagnoses. They're going to have nutritional baggage. They're going to have baggage associated with their diet. They're going to be afraid of certain foods. They're not going to want to consume certain things. And the whole goal with the newer treatments that we have for IBS and the more directed diagnosis and treatment is the idea that now you don't have to carry that baggage with you. And it's our goal to kind of help them get in that mindset. So we want to kind of foster a growth mindset. Now, that doesn't mean there's not going to be limitations, but the idea is that you are trying to expand upon a diet, make a very diverse diet, and allow yourself to enjoy food once again. You don't want to just think about restriction, especially with some of the information we have around how stress affects symptoms in IBS. If you have a negative mindset towards eating, it's going to induce symptoms, and we don't want that to happen. And finally, we want these individuals to kind of be pushed to understand that they're building their perfect diet. You want to incorporate them into the process. A lot of the past kind of treatments, we'd shove them on a low FODMAP diet, and the goal was not to keep them there long term, but people kind of come in with these preconceptions that, you're treating IBS with a single diet and everybody's going to be the same, but that's not what you want to do. After you restrict, you want to reintroduce so that you can build your perfect diet and enjoy foods the way that you would like to. Now, there are two concerning paths with diet post-treatment of IBS, and they're probably going to stratify along how long the person went from the time of experiencing symptoms to diagnosis and treatment. For the individuals that haven't been put through the meat grinder with IBS, they're not really going to think much about their diet. They're going to be like, all right, I was treated, I can eat anything I want. People do have to understand there will be limits. There are certainly issues that are genetic in nature, as well as if you're dealing with post-infectious IBS, that they're going to linger. And even though you're going to improve them, you have to understand that there may be limits to what you can do. And this may not mean that you have to completely avoid certain foods, but there may be dosages of foods that just aren't right for you. I don't have IBS whatsoever. If I eat a couple of slices of rye bread, I will get terribly gassy. I have no gastrointestinal issues whatsoever, but there's just only so much I can deal with. And that is not somebody who has IBS. They do need to understand the dose makes the poison, and even foods they were completely avoiding before, they may be able to introduce at lower proportions. And they may have some foods that just don't work. I'm going to be honest with you. I've tried to introduce beets into my diet my entire life. They're so healthy. They're disgusting to me. I'm never going to be able to eat a beet. They taste like dirt. That's me. Other people enjoy them. The other concerning path is that I need to stick with restriction forever. And this holds people back. And it also brings them down paths that are kind of troubling and concerning, especially if they're getting a lot of their information on social media. They may kind of get down this whole carbs are poison rabbit hole that ends up people going into, like very, very low carbohydrate ketogenic diets, or even a carnivore diet. And it's important to understand that you don't want to sacrifice your long-term health for short-term symptom management. There are certain things that you may feel good. Like maybe if you do a carnivore diet and you get rid of all the carbohydrates in your diet, you do feel better. But just because you feel better now does not mean that is best for your long-term health. For example, when somebody who's addicted to smoking smokes a cigarette, they feel great. That is not indicative of what it's doing to them long-term. So now the keys to success in getting the mindset going: break things down for your patients. I've found analogies to be tremendously useful. One in particular, there's a book called The Hidden Half of Nature, which effectively uses a garden as an analogy towards your microbiome, which is why I use this image to the left side of the slide. The goal in treatment with the antibiotics, let's start with a clean slate, but then you need to build back up. But if we think of your microbiome as a garden, we have to understand it's not just what you feed them, it's other things as well. So for example, if you have some tomato seeds and you want to grow tomato plants, you can't just toss them in sand in the shade, with ample water and expect them to grow a tomato plant. You have to understand that it's not just the food that they eat, it's all the environmental conditions that matter. Another thing that's important is don't overpromise. Don't tell them you'll be able to eat whatever you want, because that's unlikely to be the scenario. And you want to foster this trust between you and your patients or clients. You want them to understand that you're there to help them and keep them on the proper path, because if you start over promising and underperforming, they're going to kind of get into these social media rabbit holes. And finally, they need to understand, your patients need to understand, you need to integrate all factors. It's not just about your diet. Your diet is critically important for your gut microbiome health and your gut health overall. So that's not just dictated by what you eat. It's also dictated by, for example, your sleep, your stress, whether you're drinking alcohol regularly or not. Probably most things. There was a recent study 4 or 5 years ago that found that stress may actually increase intestinal permeability. This was a study in couples who fought, and they found that intestinal permeability markers were higher in those who were getting into heated arguments. So a lot of things matter. People need to understand that they have a lot of levers that they can press, and that gives them a lot of options. Now, building a healthy microbiome. We have two major things we're going to discuss here on the microbiome. We're going to focus on the optimizing environmental conditions. So that's things such as circadian rhythms and your lifestyle. Are you exercising? Are you sleeping properly? Are you waiting an adequate amount of time between meals? Are you sticking to the kind of same schedule day in and day out and not completely switching things up on the weekends and going crazy? Then we're going to talk about diet and eating with intent. The idea, you've blown up, you've dropped an antibiotic bomb on the microbiome, and now it's time to build and foster a healthy gut microbiome. You want to cultivate that garden, and in order to do that, you want to eat with intent. You want to eat in a way that maintains gastrointestinal health, that promotes microbial diversity. These are things people with gut problems never think about their digestive health until things start going wrong. And for a lot of these people, things have been going wrong for a very long time. And in addition to their diet, there may be other factors that they're really not attending to that we can help not only give them better gut health, but improve their overall health and maybe even kick chronic disease down the road, decades, or even eliminate the risk at all. So we're going to start on our discussion with circadian rhythms by kind of defining what they are. So circadian rhythms are oscillating biological functions that take place on around a 24-hour cycle. And it's not exactly 24 hours. In some people, it's a little less. In some people, it's a little more. Generally, most people are going to fall between 23 hours and 45 minutes and 24 hours and 15 minutes. And what these circadian rhythms do is that create anticipatory responses to the environment with the goal to increase your chances of survival. So in most of the time that we've been evolving, food has been scarce. So sequestering things to the proper times allows us to not waste energy on things that will sacrifice our long-term survival. So things like eating, repairing tissues, and things of that nature. Now, the thing to understand about the circadian clock architecture in the organism is that we have a master clock in our brain in an area called the suprachiasmatic nucleus that is effectively responding to light, but there are other peripheral clocks throughout your body. In fact, every tissue in an organ is effectively their own peripheral clock. And there are other peripheral clocks in the brain. The master clock is simply in this area called the suprachiasmatic nucleus. And the final thing to understand with circadian rhythms is they are entrainable to the environment via something called a Zeitgeber, or time givers. And what these things do is they help your body dictate what time it is. Every one of your cells has their own clock, and it's not a watch. They have a timekeeping mechanism within them that helps them kind of try to decide what time of day it is. But in order for that to work, you need to be sending them the proper signals, or they're going to run in a disorganized mess. So here's an illustration of kind of how the circadian clock works. In mammals, we have this central pacemaker in the suprachiasmatic nucleus that responds to light. When light enters the eye, it inhibits the secretion of a hormone called melatonin. You're probably familiar with it. It's produced by the pineal gland. It's also actually produced basically nearly in every cell in your body, heavily in the gastrointestinal tract. But in the pineal gland, this is used to set your circadian rhythm. So when we are being exposed to light during the day, this inhibits melatonin secretion. And after the sun sets and we're not exposed to light, we begin pumping out more melatonin. And this does several things. It helps us fall asleep, which is what most people are aware of. But it also melatonin, as well as within the peripheral nervous system, the central clock is orchestrating these timekeeping mechanisms to kind of set the peripheral clocks in a way. And they're doing this by setting your rest activity cycles. So for example, things like epinephrine, norepinephrine, they follow circadian rhythm. Cortisol is a really important one. Cortisol is what wakes you up in the morning. And this is created, these kind of circadian rhythms are created by your regular behavioral patterns. If you didn't have this and light was necessary to wake up in the morning, if you fell asleep in a cave, you would never wake up. But if you basically followed a general circadian pattern of similar wake and sleep times, feeding times, rest activity times, and then you went into a cave, you'd wake up at around the same time. And that's because you're getting these anticipatory responses due to these circadian rhythms and the clocks found in your brain, as well as in the peripheral clocks throughout the body. So here we have another kind of look at the master clock. The master clock drives these behavioral patterns, whether you're going to sleep, whether you're awake, or whatever. But additionally, it has a direct effect on the peripheral clocks, which kind of helps them get a general sense of the time. And then you're driving these behavioral patterns that are then synchronizing these peripheral clocks. So let's break it down a little bit. You have clocks in your muscle. Your muscle clocks during the daytime, they are taking in fatty acids and they're focusing more on glycolytic metabolism, breaking down carbohydrate and effectively more towards the anaerobic energy systems. But at night, there's a shift towards the oxidative metabolism in the muscles. And this helps the muscles work more efficiently. Again, we're talking about rest activity cycles. So think of your activity cycle when you're active as damaging tissues and that rest cycle when you are repairing them. So we're having these kind of alternating cycles throughout the day to help us live through our environment, but then allow us to repair for the next day. Additionally, when we look at like the pancreas, it's secreting insulin during the day because we're eating, and during night it's secreting glucagon because we're fasting. Now, the problem is all these clocks, for example, when you're looking, say, at your blood sugar, you have a lot of things regulating your blood sugar, your hypothalamus, your gut, your stomach, in fact, it delays gastric emptying when blood glucose levels climb. Your pancreas, your liver, your fat, and your muscle. These are all adrenal glands, your kidneys, they're all regulating your blood glucose level. So it's important for them to do that effectively, that they know that they're on the same time, so they know what they're supposed to do. When we have disorganization, that's when we lead to pathology. So the primary zeitgebers or time givers in the circadian system are light, which exerts its effect on that master clock that then kind of regulates the peripheral clocks due to these activity cycles. But what we're doing with light is we're syncing our master clock to the day-night cycle. So it's tethering us to our environment. Now, the other major zeitgeber is core body temperature. Core body temperature is doing something different. First and foremost, that master clock is regulating your core body temperature, but that master clock is not responding to temperature. If it did, it would basically be regulating itself, and that wouldn't be good. It's regulating our core body temperature, and it's initiating, for example, exercise, movement, feeding, things that increase our core body temperature. When we're increasing our core body temperature, this is synchronizing all of the peripheral clocks. It's taking the individual clocks within each cell of an organ or tissue and organizing them together. It's taking that master clock and synchronizing it with the peripheral clocks. And then it's taking the peripheral clocks and allowing them to synchronize with one another. These clocks may not speak exactly the same language, but one language that they all speak is temperature. They all have heat shock proteins. When you increase body temperature, they respond accordingly. Additionally, food is a really important zeitgeber. And if you think about it, it's one of the most important factors in your survival. You need to eat in order to survive. So feeding time is really important. It regulates these peripheral clocks heavily, in particular the liver, which is, effectively the central regulator of metabolism. It's really important. And metabolism in and of itself is important because, again, just like temperature, metabolism is a language that every one of your cells speak. So food is clearly a really important zeitgeber. Now, your feeding window, meaning the period of time when you're eating, is more important than meal frequency from a circadian perspective. That doesn't mean that meal frequency doesn't matter, but in terms of regulating your circadian rhythms, your feeding window, the periods of time during the day that you're feeding, matter most. And meal size is going to matter too, because if you figure your last meal of the day, if it's huge, you're going to be processing that for a very long time, delaying the resetting of the clock. But this brings us to a question that's really important. What is this mechanism within feeding that is regulating the circadian clock, also known as the food entrainable oscillator? And based on the evidence we have today, insulin and insulin-like growth factor 1 signaling are these food entrainable oscillators, and it makes sense because they're regulating growth. And as mentioned, you have growth and repair that we're regulating with these circadian rhythms. So it's really important that you have good insulin sensitivity. And furthermore, insulin and the insulin sensitivity throughout your body, as well as what insulin is doing, is actually regulated pretty well under this circadian clock. So again, as I mentioned, cortisol wakes you up in the morning. Cortisol is kind of a counter-regulatory hormone towards insulin. Cortisol increases your blood glucose, insulin decreases your blood glucose. But we can even go a little deeper. Based on recent research, it seems that melatonin plays a role in insulin. And what it does is it inhibits insulin secretion, which, if you think about it, we're making more melatonin from the pineal gland at night. We're about to go into a fast. We do not want insulin being secreted at this time because that could drive our blood glucose levels down. So with melatonin inhibiting insulin secretion, that allows our blood glucose to not drop too low while we are asleep. Additionally, further evidence has shown that your melatonin levels overnight actually play a role in regulating your insulin sensitivity. So there you have the importance of good circadian rhythms on insulin sensitivity. But it's important to point out that insulin sensitivity is essential. If insulin is the food entrainable oscillator, if you're insulin resistant, your cells, your organs are not going to get that signal. Now, of the, basically every organ and tissue in your body, circadian rhythms is important, but GI function is heavily circadian. Again, you're syncing multiple organs to regulate things such as blood lipids, blood glucose levels, gastric hormones, enteroendocrine cell turnover, things of that nature. You need to synchronize all this stuff, because if you're not doing that, it can lead to pathology. So you have your gastrointestinal tract, which is a peripheral clock within you, but it's also important to understand that the microbiome as a whole and individually, that has a circadian rhythm too. And you need to regulate that microbiome in a way so that the microbiome is synchronizing with the peripheral clock in your gastrointestinal tract, and therefore with the rest of your body. Further, we have the gut-brain axis, which is, you can't really speak enough on that. It's so important. It's all the stuff we're finding on it is very interesting. But just to understand, you're synchronizing multiple organs within you, and then a separate organ that isn't really yours. The genes belong to these bacteria, archaea, and fungi in your, even the viruses in your gastrointestinal microbiome. So with the microbiome, it's really interesting if we kind of think about how this works, and the fact that your feeding and fasting cycle is really important. We can think of what's happening with the microbiome. So during period of time, your active period or your day period as a diurnal human, your microbiome is going to be kind of breaking apart dietary glycans. But then you're going to be entering a fasting phase. And then that microbiome is going to have to turn onto you and start fermenting your glycans, the glycans you're making in your mucus layer. So it's important to understand that when you eat is going to regulate this microbiome. And if you don't have these patterns of eating and fasting, that you can really mess up this microbial clock within your gut. So what we're looking for by synchronizing all these things is these anticipatory bumps that we would get due to these regular behavioral patterns. And these are going to lead to better digestion and better absorption of your nutrients. As we all know, the microbiome plays a role in helping you break down food. It also plays a role in helping you absorb it. So here we have a slide. This kind of shows us what we're looking at under circadian homeostasis and circadian misalignment. So under circadian homeostasis, getting regular sleep and wake times, avoiding light at night, eating on schedule, not eating late. And the GI functions that we are regulating are cell proliferation, gastrointestinal motility, protein, lipid, and carbohydrate digestion and absorption, electrolyte absorption, barrier function. If you think about it, you're sloughing off cells from your gastrointestinal tract, and you don't really want to have food down there when that's happening, because you're going to have greater permeability. Additionally, the mucus layer follows a circadian rhythm. Again, the microbiota community and immune function all following significant circadian rhythms. You're going to be more sensitive to inflammation at certain times of day than others. And when we do things that kind of disrupt this circadian homeostasis, we get into problems. Metabolic syndrome, barrier dysfunction, dysbiosis, traveler's diarrhea. And if you think about it, when you typically travel overseas, you're skipping time zones, you're screwing up your circadian clock, and then you're eating foods and being exposed to microbes that you're not normally exposed to. So this really is kind of like a worst case scenario. Ulcers, gastroesophageal reflux disease, inflammatory bowel disease, all these, for the most part, all of these gastrointestinal problems have been associated with circadian rhythm disruption. Here we have the circadian motility patterns. We'll break this down pretty easily. Migrating motor complex, which it's cleaning waves, are more frequent, stronger, and faster first thing in the morning. Colonic motility, again, same deal. It's greater in the morning. You can induce it by a large meal and or coffee. And the important thing is that large meal is at the same time of the day, every day. That's going to cause this kind of synchronization of factors that just kind of induce colonic motility. So you'll have a bowel movement. And it's important to point out that, okay, I wake up and, that's when I should do it. This requires good circadian habits. This is subjective time of day. This isn't just looking at your watch and being like, oh, okay, it's 7 o'clock time for a bowel movement. You need to be observing good circadian habits so that the cells in your body understand what time it is, and they're the ones doing the work, not the clock on the watch that you're looking at. So we have several different types of disruption, circadian disruption, that causes misalignment. There's behavioral disruption. The classic versions are night shift and jet lag, which most of us have experienced somehow, some way or another. But another important one that all of us experience pretty much consistently is social jet lag. And what is social jet lag? Social jet lag is, I work a 9 to 5 during the week. So on Sunday through Thursday nights, I'm going to bed at 10 and I'm waking up the next day at 6. And then Friday, I'm going out with my friends and staying out till 2 o'clock in the morning, waking up later on Saturday, doing the same the next day. And then you need to switch again. So you're disrupting yourself 2 times in a week and basically staying in a disrupted state for most of the week. That's not great for gastrointestinal health. Western diet, as well as alcohol, have been shown to disrupt circadian rhythms. Poor sleep and eating habits, for example, staring at your phone when you should be sleeping, or watching things that excite you right before bed, or maybe deciding to have that late night snack. These can all disrupt your circadian rhythms. Metabolic disruption, being obese disrupts circadian rhythms. Now, these are all going to kind of fall under the same kind of umbrella here. Obesity, type 2 diabetes, and insulin resistance, infection and inflammation. Inflammation disrupts the circadian clock. So just because, for example, like say you find that the cells in the colonocytes are having an impairment in their genes related to circadian rhythms, that doesn't mean you're just going to bed at the wrong times. With inflammation, that disrupts the clock. Infection, a lot of infectious agents, they are able to infect you by disrupting the clock. Others, they actually try to synchronize your clock to infect you. So we have this behavioral disruption, but we also have the metabolic disruption. And even if your behavior is perfect, if you are experiencing metabolic dysfunction, such as insulin resistance, you are not going to have good, robust circadian rhythms. So what are good circadian habits? What are the important things we need to do? First, stick to set sleep and wake times. That includes the weekend. Generally, try to get to bed within an hour. You can adjust to a change in time. So for every hour you shift your clock, it will take a day to adjust. So try to stay under that. Even within a half hour of your sleep and wake times is ideal. Stick to set meal times, in particularly that first and that last meal you want to keep at the same time. But there are other beneficial effects of keeping your meals times, even that middle meal if you're having 3 meals at exactly the same time. And be active during the day and relax at night. What's one of the best ways we can increase our core body temperature? Get up and walk around. Furthermore, from a digestive perspective, increasing your body temperature, when you feel your body temperature increase while you're walking or exercising, you are shunting blood away from your digestive tract, and it's still basically participating in oxidative metabolism. So it's going to have to pull that oxygen from somewhere else, and it's probably going to be the lumen. During exercise, you can see about a 50% reduction in blood flow to the gastrointestinal tract. So it's going to be helpful to kind of decrease the amount of oxygen. At least that's the theory. The 2 basic theories of how exercise improves the gut microbiome are increasing body temperature, as well as this, relative ischemia during exercise. But it's important to point out you don't want to do it too much, because when you exercise for too long and too hot environment, too intensely, you do experience barrier disruption. So we're going to kind of break down what are examples here. Pick a sleep window that's 8 to 9 hours long. The reason you want to do that is you're generally going to lose about an hour between falling asleep and, tossing and turning a little bit, whatever, maybe getting up to go to the bathroom. So for example, my sleep window is 8 hours long. I go to bed at 10 p.m. I wake up at 6 a.m. This now gives you how you can dictate when your feeding window is, which should be between 10 and 12 hours. You can restrict it more if you want, but you don't really need to. You want that feeding window 10 to 12 hours, and you kind of want to delay eating when you wake up 1 to 3 hours. And why is that? As I mentioned, the migrating motor complex is strongest and longest in the morning. So it would be great to get a couple cycles in before you consume your food. You're already fasted, so it's really not a chore to fast longer. And from a circadian perspective, you're actually going to get stronger waves anyway, because that's the behavioral patterns you set. So 1 to 3 hours, if you go 3 hours, you'll get around 2 cycles of that migrating motor complex, which will help clean out the gut. Next, don't consume food within 3 hours of bedtime. There's a couple reasons for that. As I mentioned, melatonin can inhibit insulin secretion. Furthermore, consuming food causes your core body temperature to increase. And if anything, you want to drop your core body temperature before you go to bed. That's a signal that it's time to go to bed. So my feeding window is 9 a.m. to 7 p.m. I get a full 3 hours from waking up and a full 3 hours before going to bed. You want to optimize your light exposure. You want to get light early in the morning. That exposure to light is setting your clock. And ideally, you're getting it within 1 to 2 hours from awakening. Ideally outside, because we're shooting for, in terms of light intensity, 1,000 lux or more. You're not going to get that from indoor lighting. Even if you are using one of those SAD lamps, which has 10,000 lux, you need it like this far away from your face. Going outside, even on the cloudiest day, you're probably going to see about 20,000 to 30,000 lux. Of course, if you do need to use a SAD lamp, it's a perfectly good option. Just realize and make sure that you're using it in an ideal situation so that you are getting the 1,000 lux. Additionally, getting exposed to light during the day more makes disruption at night from light less effective. In other words, you're less sensitive to the light you're exposed to at night if you've been getting adequate light exposure throughout the day. Having said that, you still want to limit your exposure to light at night. Dim the lights down. Blue light in particular is really important for the clock. So if you're using lights in your house, you either want warm lighting or incandescent lighting. You don't want it overhead because the receptors for that light are actually in the bottom of your eye. So if you have, if you can keep them down on, say, like a table or even floor lighting, that's better. Blue light devices, your phone, tablets, things of that nature, you definitely either want to reduce the intensity altogether or use a blue shift mode or a night shift mode to decrease the amount of blue light you're being exposed to at least 3 hours prior to bedtime. If you're wondering about a television, provided you're not 3 inches from the television and you're sitting a normal distance, TV is really not going to have that much of an effect, but they do make blue blocking glasses if you prefer those. Thing is, the ones that work really well really make it difficult to walk for some people. Meal patterns, equal spacing. So we have 9 a.m., 2 p.m., and 7 p.m. The reason behind the equal spacing is that if we can, we do want to get some of those migrating motor complex patterns in between meals. You're going to have to digest your meal and then eventually be in a fasted state for those to happen. That's not going to happen if you eat breakfast and then 2 or 3 hours later you eat lunch. And you want to go from larger meals in the morning to smaller meals at night. Digestion is better in the morning. Furthermore, insulin sensitivity is better in the morning. So you can have your carbohydrates at that time too. And that'll actually kind of give you that insulin bump that you would get in the morning to help set your circadian rhythms. So now we're going to discuss our nutritional goals. Post IBS treatment, we want to personalize the diet, and we want to focus on optimizing the gut and promoting microbial diversity so we don't get that skewage towards hydrogen producers that we get during IBS. We want to avoid going backwards. So the backbone of the diet, clearly low fermentation is the way to start. You definitely don't want to stick there, but you don't want to be dropping a whole bunch of fiber down into your newly cleared out gut. You want to include fermented foods as they promote diversity, which we're going to discuss momentarily. And then you want to slowly introduce prebiotics. And I like to start with polyphenols, and we're going to discuss why. So the Phi-FIFO study, if you haven't heard of this, this comes out of Chris Gardner's lab out of Stanford. And they wanted to see how fermented foods and fiber in the diet impact both immune markers within the blood as well as gastrointestinal microbiome diversity. And the results of the study were pretty interesting. They found that fermented foods increase diversity, and they were consuming 6 servings per day of things like yogurt, kimchi, kefir, kombucha, something called gut shots, which is effectively the brine from fermented vegetables. And they found that people consuming these 6 servings per day of these fermented foods saw an increase in diversity. And it wasn't just the microbes they were consuming in the fermented foods, it was other microbes as well. It's as if they were introducing keystone species that were bringing along friends over time. But they found something interesting on the high fiber diet, and this stratified on microbial diversity, meaning those who had microbiome diversity saw lower inflammation from a high fiber diet, whereas those with poor diversity saw higher inflammation. So what does this study tell us? It tells us that fermented foods are what we need to include to kind of push that diversity forward before we can begin introducing more high fiber foods. Now, there is one problem with high fiber foods, and that is that they are higher in sodium. And that is a segue. So sodium is something basically people don't concern themselves with unless they have high blood pressure. And this is a mistake because there are a lot of problems that high sodium diets can cause over time that people just don't think about, particularly with the blood vessels that can cause endothelial dysfunction. But the way that they cause that within the blood vessels actually could happen in the gut as well. So you've probably heard of villi, and our villi have microvilli, but your microvilli have their own microvilli, which is more a slime coat called the glycocalyx. And all the information we have on this glycocalyx comes from looking at the endothelial glycocalyx, which is the one in your blood vessels. But throughout the body, every cell has a glycocalyx, and the structure is effectively the same everywhere. All of the epithelial barriers have a glycocalyx, particularly the gut that we're going to be discussing, the intestinal glycocalyx, but every cell has a glycocalyx to protect it. Now, what does the intestinal glycocalyx do for us? Well, for one, it's for lubrication and protection. As you can see in the image on E here, we have the glycocalyx, and it's keeping things in the lumen away from those microvilli. Additionally, this is where the mucus layer is kind of being secreted from and attaching to. So it's also called a slime layer. And basically, if you've ever felt seaweed, that is a glycocalyx, and you'll learn something about that momentarily. It's also a physical diffusion barrier. As you can see, there are holes here, and large particles are not going to be able to get through it. They're going to need to be broken down. It's going to act like a sieve, and the smaller particles are going to be able to sink down into it. That includes bacteria as well. We want to keep them away. In line with that, it functions as an electrostatic exclusion zone. We'll discuss that more in depth on the next slide. It's not just a physical barrier, it's repelling things electrostatically as well. What else do we find in this glycocalyx that might be important for gastrointestinal health? Well, it houses the antimicrobial peptides that are effectively the brush border. The glycocalyx is part of the brush border. Therefore, it also contains brush border enzymes. Furthermore, it's an attachment site for commensals. Commensal bacteria actually attach to this glycocalyx. So if we do not have a good glycocalyx, we're allowing bacteria to get closer to the cell walls in the intestinal barrier. We are allowing enzymes and bile acids to kind of encroach upon areas that we don't want them to encroach upon. And we're not holding on to these antimicrobial peptides in the event that they do slip by. We're also not breaking down our food because we're not holding on to these brush border enzymes. So I mentioned that the glycocalyx, the intestinal glycocalyx, all of the glycocali are negatively charged. They form an electrostatic barrier. So that is going to repel things with a negative charge. As I mentioned, all cells have a glycocalyx. That includes bacterial cells. And bacterial cells, their glycocalyx has a negative charge too. So our glycocalyx being in a healthy state creates this negative charge that repels bacteria who also have a negatively charged glycocalyx. In fact, bacteria really don't become a problem until virulence factors cause them, for example, to make these pili that can actually grasp onto the glycocalyx, and then they can create what are called shedases to cause your glycocalyx to break down. Furthermore, your bile acids have a negative charge, particularly the water-soluble ones. So they are repelled from your intestinal barrier by this glycocalyx. Now, an interesting fact of the glycocalyx is that it will bind positive ions. And one of the ideas about why this is so important in all cells is sodium has a positive charge. And you don't want sodium just flooding into your cells. So having something that can bind them and slowly introduce them into the cells so that they're not causing swelling is really important. Furthermore, binding these positive ions can cause problems because as that negatively charged glycocalyx binds more positive ions, this causes the glycocalyx to collapse. And what do we see in a high sodium diet? We see a lower amount of lactobacilli in the gut microbiome. This may be due to glycocalyx collapse caused by excess sodium, not allowing you to have these lactobacilli attaching into your glycocalyx. So what damages the glycocalyx? Surely mentioned high sodium, but it's not the only thing. Hyperglycemia damages the glycocalyx. Inflammation and reactive oxygen species. Interestingly, the glycocalyx also prevents your own immune cells from inadvertently getting into your cells and causing problems like damaging your own cells. And so when we have inflammation, this causes our cells to secrete these shedases because with inflammation, they're kind of assuming an infection and you want those immune cells to kind of clean things up. But chronic inflammation, chronic reactive oxygen species is just going to damage this layer, and then it's going to cause all sorts of problems. Alcohol damages the glycocalyx and infection. As I mentioned, some of these virulence factors within different bacteria and other microbes, they are in there to damage the glycocalyx so they can infect cells. So what can we do to strengthen the glycocalyx? Well, one, consuming less than 2.3 grams of sodium per day is, I think, really important. Additionally, we know that sodium is a preservative and it inhibits microbial growth. So you really don't want to put that in an area where you actually want healthy microbes to grow. Dietary precursors also improve the thickness of the glycocalyx. Glucosamine, chondroitin, hyaluronic acid. These are the glycocalyx is made out of highly sulfated proteoglycans, glycoproteins. There's some glycolipids in there as well. So we want to provide the dietary precursors. Red seaweed contains a prebiotic called fucoidin, which actually inhibits one of these shedases known as heparinase that breaks down the glycocalyx. So consuming seaweed can be beneficial as well. And interestingly, again, a lot of this information is coming from evidence on the endothelial glycocalyx. Insulin seems to be about the most robust strengthener of the glycocalyx. There was a recent study. What they did was they caused hyperinsulinemia, but they kept euglycemia, and then they fed them high or low sodium diets to see how that affected the glycocalyx. And the effect of insulin on the glycocalyx was so strong that the low and the high sodium, there was no perceived difference in the high and the low sodium conditions on the glycocalyx. The insulin was just a robust inducer of glycocalyx lengthening. So now we're going to move on to dietary polyphenols, really beneficial, as I'm sure you're aware of. All different sorts of polyphenols. Generally, you look at the colors of fruits and vegetables, those are the polyphenols. Polyphenols can act as a prebiotic, and they don't have the added problem of excess hydrogen produced during carbohydrate fermentation. Additionally, certain prebiotics have been shown to promote butyrogens over some of the other competitive species we find in there. They also can oxidize hydrogen sulfide. Anthocyanins have been shown to do that. So if you have excess hydrogen sulfide, polyphenols can help break that down so that it's not problematic. It doesn't thin out your mucus layer and cause problems. They also have an antioxidant effect that you're probably aware of. So they'll reduce reactive oxygen species. And a multivitamin. People ask me about this a lot. Yay or nay on the multivitamin. Anything that supports host health is important. A lot of these people with IBS are coming in from a very poor diet. Additionally, they just dropped an antibiotic down there. So they may have issues with some of their microbial produced vitamins. So it's important, I do think, that a multivitamin is used. the vitamins act as cofactors for metabolisms and then therefore are important for circadian rhythms. Interestingly, a study showed that B12 may block methanogens. So as I mentioned previously, butyrogens are going to compete with methanogens. They kind of compete with one another. They do kind of work together, but they are competing for resources, and B12 may actually kind of promote that butyrate production over the methanogens producing methane. So here we have just the B vitamins and what they do, the different species that make them. I'm not going to jump into each and every one of these. Just realize that the kind of peach shade are the microbes involved in the vitamin biosynthesis. If you drop an antibiotic down there, you're going to kill off some of these guys, creating potential deficits. And we can look at what the deficiency effects are. And there are a number of problems with deficiency in B vitamins on gastrointestinal health. Alcohol. Alcohol has been shown, as I mentioned, it will degrade the glycocalyx. High methanobrevibacter smithii and alcoholic liver disease. Same with Klebsiella pneumoniae as well. When we look at what happens when we process alcohol, alcohol is processed by our liver eventually into acetate, and this can cause an expansion of acetate metabolizing microbes in your small intestine. Furthermore, Bacteroides, Theta iodomicron, and Methanobrevibacter smithii compete for acetate. B Theta iodomicron is going to kind of shift probably more towards the butyrate production. Methanobrevibacter are not using acetate to make any sort of byproduct, but they are dependent on it for their growth. Well, we see really interesting study. When hydrogen levels are high, methanogenesis seems to be preferential towards butyrogenesis. However, when we're looking at Bacteroides theta iodomicron, vitamins B12 and K both prevent this inhibition from a high hydrogen environment. Now we're going to talk about something called taurine. It's a sulfur-based amino acid. So clearly, if we're dealing with somebody with hydrogen sulfide issues, we want to take a careful, measured approach here. Taurine is conjugated to our bile acids in our liver. It makes them more water soluble, and whether or not they're conjugated with taurine or glycine is dictated by taurine availability. The more dietary taurine you consume, the more you're going to conjugate taurine. We have bile salt hydrolases in our microbiome that deconjugate these bile acids and free up taurine. Now, taurine, I'm sure some of you have seen the data behind this. You get an infection, say with Klebsiella pneumoniae, resolves. You see an expansion of taurine utilizing microbes, and this has a beneficial effect. This creates hydrogen sulfide, which inhibits aerobic pathogens, and therefore it's going to inhibit things such as E. coli and Klebsiella pneumoniae that are using aerobic metabolism to increase virulence. But if you're using taurine, you should see a net hydrogen sulfide decrease because you're going to have less hydrogen in the presence of less E. coli and Klebsiella. So we're going to sum up the dietary approach. Best dietary approach based on everything I just discussed with you. What's the best dietary approach? And that would be a Mediterranean diet, which seems to be beneficial for most anybody. High in polyphenols, high in good fats such as omega-3s, and it can be high in fiber. It doesn't necessarily have to be, but the goal would be to increase fiber over time. Also contains fermented foods, and it's generally low sodium, particularly if you do the DASH version of the diet. So you want to start with this kind of this backbone of the Mediterranean diet. Start low fiber but high polyphenol. You're also getting the fermented foods to increase diversity. So then you can gradually over time increase fiber. Definitely look into the supplemental multi. The one I recommended, or that was actually in the image earlier, is Baby and Me Too. No, I'm not expecting, but Baby and Me Too offers minis. So you're getting between 40 and 80% of the USD RDA, or the recommended daily allowances of these vitamins, rather than taking mega doses, which God knows what's that's going to do. You're not going to absorb it all. And optionally, taurine up to 2 to 3 grams per day. 3 grams per day is shown to be safe in humans, and in fact, up to 6 grams per day have been used. You may have heard the recent study on taurine in lifespan with mice. Over time, we do make less taurine, and based on that study, 2 grams per day would be what you would replenish to kind of stay consistent on your taurine levels as you age. Whole foods, stick with whole foods, stay away from the ultra processed foods. As you know, preservatives and food additives can be problematic for the microbiome. Diversity is the name of the game. You want at least 30 different plants per week if you can. And calorie restrict to a healthy BMI. That's going to keep you metabolically healthy. It's going to lower your inflammation and make you feel healthy overall. So with that, do we have any questions?
Dave, can you hear me?
Yep.
Excellent talk. I certainly, I mean, every time you pump out a video or something, I'm like, you know, having my fasting black coffee in the morning. I certainly enjoy your videos and your teaching, and it was very insightful. So, are there any questions from the audience? The host, what is it? So, Dave, the question was in regards to shift working. As we know, circadian rhythm has three major overlying cycles. So the light and the dark cycle, the fasting and the feasting cycle, and of course the exercise and rest cycle. So those are the three cycles that we have in our inherent circadian rhythm. The question from the crowd was, what do we do in regards to people who have night shift working?
Yeah, it's difficult and it's really dependent. So you really need to understand what their needs are. So for example, somebody might work night shift, but they may still want to consume their meals with their families. So it depends what their night shift is. Night shift can mean a lot of things. Night shift can mean until, like, you know, you're working from say 3 till 11 or 3 p.m. till 11 p.m. or it can mean you're working from 11 p.m. until 7 a.m. So it really, really depends. I can kind of give you an example. I have a friend who works the night shift, specifically the one I just told you. He works from 11 p.m. to 7 a.m. And he was asking me what he should do. And he wants to keep it relatively consistent. That's the important thing. So most people are going to work, say, a 5-day, you know, work week. You can't change it up. It's got to stay the same. So you've got to, as long as you're staying the same, you're going to see the benefit. So for example, with him, he would come home at 7 a.m. and he would try to sleep. And then he'd wake up, you know, he's 1 o'clock in the afternoon. And it's still, you know, he doesn't have gastrointestinal issues, but you still want to wait a little bit because that's their subjective morning. So wait a couple hours, eat. So that will put his first meal around 3 p.m. He actually compresses his eating window. So while I recommend, like, for your average individual, 10 to 12 hours, he compressed his down to, I can't remember if it's 6 or 8, which allows him to get his eating in with his wife and kids, so that they are sharing that time. But then he's kind of opposite. He's fasting for a lot of his work, but you have to keep in mind, yeah, he's at work, but my friend actually kind of he works for the U.S. Postal Service, so it's not like he's running around. He's sorting mail and stuff like that. So he's in a seated position. He keeps the lights low, unless he's tired, and then he kind of cranks them up. But keeps most of his quote unquote feeding and active periods still during daylight hours, at least half of it. That works for him. Somebody else that might not work for. And if you're single, I mean, personally, what I would do is I would just flip it. I would go, if, say I'm working 11 p.m. to 7 a.m. and I'm just going to stick with that, then 11 p.m. to 7 a.m. is my active period. Now, that's not to say that is not good for you. And definitely if you're in your 20s, that's something you can get away with a lot more than when you get in your 50s, 60s, and 70s. So you also have to take that into consideration. When you're younger, you're more robust and you're kind of more flexible. As we get older, our clocks just start working less effectively. So those things become more of a problem later. Fortunately, most of the time, the night shift is kind of something the newbies get, and so you can kind of shift towards a more normal pattern as you get older. But yeah, it's going to depend. Additionally, like, my friend doesn't need to be super alert sorting mail, but a cop or like a paramedic, they absolutely need to. So in that instance, during their period, since it's such high stress, they're going to be dealing with stress. They're going to want to expose themselves to lights and occasional stressors during that period of time. Yeah.
You. Very important question, Dave. Can you walk me through the morning in regards to fasting, migrating motor complex, and coffee?
What do you mean? Oh, using. Oh, I got
When
you. I think I got you. Yeah.
when can I consume coffee? And what can I put in it? Should I drink water beforehand? Should I wait a certain time frame until I drink my coffee? I see a
Yeah.
lot of heads nodding yes in the crowd. I think that's a burning question.
Yeah. You will all be happy to know that you're fine with drinking your coffee in the morning. In fact, I told you so. Kind of depends on what your goals are. I don't have any gastrointestinal problems, so theoretically speaking, coffee. If you have gastrointestinal problems, coffee might be an issue because it's high in polyphenols. But for example, I mentioned, I eat my first meal at 9. That's not including my coffee that I have at 7 a.m. I don't put anything in my coffee. Once you start putting calories in, yes, it does matter, but there's going to be limits to that. If you put like a very tiny amount of, I wouldn't necessarily put sugar in there, but if you consume like a very tiny amount of milk, I don't think we really have an exact, this is how many calories you could consume without disrupting your migrating motor complex. But keep in mind that coffee generally will promote motility. In fact, there was a study looking at the effects of coffee on the gastrointestinal tract. And if I remember correctly, one of the clear findings was it did cause a like bile acid release. So this, not excessive bile acid release. It might even be the kind of that little bit you get at the beginning of the cleaning waves to kind of, put an antimicrobial on before you push down the road. But if you want to know if it's disrupting yours, and I can tell you through personal experience, if you're by the time you get to 9 o'clock, your stomach should growl. There's a hormone that you're all probably aware of, ghrelin, that was just really interesting. When you keep your meal patterns on the exact same time schedule, you will get that a huge surge of ghrelin right up till that time that you consume food. Makes sense because it's kind of a motivational hormone, which is kind of motivating you to find food at times when you would normally be exposed to it. So you will get some, if you get the growling, the standard growling, you're almost certainly not disrupting that migrating motor complex. If you're drinking black coffee, I wouldn't worry about it at all. If you're keeping the calories pretty low, I think you're fine as well. Like if I were to put, I would put it this way. I wouldn't go to Starbucks and get a Frappuccino, but if you wanted to put maybe a little bit of honey or a little bit of milk, maybe get it up to like, I don't even, like a gram of fat is going to be about 9 calories. I don't think if you're going up to 20, that's really not a lot of fat, but if you're going up to 20 or 50 calories, that you're really going to disrupt that migrating motor complex. But again, like I said, use that stomach growling as indicative. If you get it and then you stop getting it, then you probably should look to cutting back on the calories in the coffee.
Any other questions?
So am I popping out of here?
Okay.
You want to stay on for a
Sorry,
second?
Dave, we have one last breaking question here.
Okay.
Intermittent fasting, it does not follow recommendation to follow a regular cycle of sleep and eating, but many people advocate the benefits of intermittent fasting. Your thoughts on intermittent fasting?
Oh yeah. So it depends what you're talking about. So my personal, my personal approach is time restricted eating during certain parts of the day. Again, for me, that is 9 a.m. to 7 p.m. I think 90% or more of the benefit from intermittent fasting is going to come from calorie restriction. I think it's a valid form. If it works for people to bring their calories down, it's fine. If people are looking at it as kind of, this is a magical way for me to be healthier, I really don't see that. I do think it's important from time to time to give the digestive tract a break, but I don't think you need to do a 24-hour or 48-hour, 72-hour fast to do that. If you like it and it doesn't lead to disordered eating, and you feel okay with it, I don't think there's anything necessarily wrong with it. Of course, if you're underweight or if you're a woman looking to get pregnant, it's definitely not something I would consider. It can also be problematic for menopausal women because of the whole body temperature regulation stuff. But intermittent fasting is effectively, if you're looking to it as a health intervention, if it leads to calorie restriction, it's good. If you can do calorie restriction another way, it really doesn't matter.
I think that's it. Thank you again, Dave, and all the best.
Great. Take care.